Hello everyone. We're going to briefly talk about logic and just some basic concepts to keep in mind when you study this particular topic. Why don't we start off with the notation P? We're going to let P represent a statement, and for example, we can say for P, we could say 4 is an even number. Okay? So this is just one example of a statement. P could represent any statement you would like. Since we're dealing with mathematics, we can just use something like this. Once you have a statement, or it's also known as a proposition, you can negate this statement, okay? And this is highly mentioned in logic, where you have statements and then they're often negated to see what would happen if we negate a statement. What does that actually mean, okay? Well, if you look at negation, okay, simple definition, okay, it's basically the opposite truth value of an original statement, okay? And I'll explain what that means. Okay, the original statement. So keep in mind, the original statement we have is, 4 is an even number, okay, in red. All right, so I want you to keep that statement in mind. All right, and we're going to negate it. And what does that mean? Okay, as additional piece of information, the symbol for negation is basically this tilde. All right, so if you have a statement, original statement that was P, which is 4 is an even number, then we're going to use this symbol, this tilde, meaning the negation of P, or better known as not P. Kind of like the negative, right? Negation, negative. Now, when you negate a statement, okay, it's really important to keep in mind that it is not necessarily false. Just because you negate a statement, it does not make it automatically false or not true. So if we take the negation of 4 is an even number, okay, and we do the negation of that, then keep in mind that we have 4 is an even number. This is the original statement P, right? And if we negate that, then that equates to 4 is not an even number. Now, is that true? Is 4 not an even number? Okay, of course not. Definitely not. 4 is definitely an even number. The negation of the statement is telling me 4 is not an even number. So this is a perfect example that it's not necessarily false. Okay? So, again, you can negate any statement, whatever your statement is, you can negate it, and you basically use the word not. This is the key thing here, okay? You use the word not. All right? And that's what a negation of a statement is. Okay, the next thing is I just want to talk briefly about De Morgan's law, okay? Excuse me. Let me just go ahead and make this easier to see here. So, again, I'm just going to talk about this briefly because This is used a lot in electronics, believe it or not, computer engineering and things like that nature. So basically, and we're going to talk more about this later on when we talk about and or, which is junction, disjunction, that kind of thing, with propositions or statements. Okay, so you can have two statements. Okay, one statement's going to be P, and the other one's going to be Q. Okay, and the V that you see stands for or. So, if you have a P statement or you have a Q statement, it's two different statements. Okay, so very often it's a lot of symbolism here. So this here represents and. Okay, and the V stands for or. In this particular case, we have the right side up V there, so this is going to be or, okay? And that's the difference. You got to remember which one is which, okay? You can negate these two statements, okay? And when you do that, okay, that is the equivalency of, I should have actually moved these over. Let me go ahead and erase these, and I'm going to move these over so I have a little more room here, and I'm going to put all the notation up in this upper right hand corner. Okay, so V is for or. Okay, that equals or, and then the upside down V is and. Okay, and again, your tilde is your negation, remember, which is not. Okay, and of course P and Q are statements, all right? And it could be any statement. This is just, we're just using symbols here to denote a representation of something, okay? So you can have a P statement or a Q statement, and you can negate both of them, and that's the equivalency of normally this little double-sided arrow can be replaced with. So anytime you see that, you can say can be replaced or just replaced to make it a little bit simpler, okay? Replaced with a different statement. So the negation of P or Q can be replaced with the equivalency of this, the negation of P or the negation of the Q statement. It's identical. It's just rewritten in a different way, but they both mean the same thing, okay? It almost looks like they're distributing the tilde, right? Kind of when you think of a distributive property and whatever's outside the parentheses gets distributed or multiplied or attached to whatever's inside the parentheses. Think of it like that if it helps you remember it better, okay? And of course you can do the same thing if you have the negation of P and Q. When the V is upside down, that represents and, okay? And that can be replaced with the following statement. The negation of P, okay, the negation of P and negation of Q. Now I want you to notice one thing here, and I didn't quite mention it yet because I didn't want to confuse you. So if you look at the original one that we did here with the P or Q, this can be replaced with P, the negation of P, and the negation of Q. You notice the symbol has changed. And then here we started off with and right? And then now we have, this can be replaced with a negation of P or the negation of Q. That's what you have to remember. That is the equivalent statement of that, okay? So it changes, but in logic, that's how it would make sense. So just to make sure you understand, like, the terminology, the symbols, you know, because that's 50% of the battle is, you know, what do these symbols mean, you know? None of this would make any sense if you don't have a clear representation of what each symbol means. So it's so important to look at this little key I made for you in the upper right hand corner. All right, take a look at that and really study that first. Make sure you know all the symbols, what they mean, so that when you put in statements for P and Q, you will know how to read them. Okay, so that's like super important. Put a little asterisk there to keep in mind that you have to look at that and make sure you're okay with that terminology. All right. We're actually going to talk about a lot of different things here. Another one would be contrapositive, if I can just get that. Okay, so let me go ahead and maybe just change colors here. Contrapositive. And all that means is you're switching the hypothesis and conclusion of a conditional statement and negating both. Okay, and I'll give you examples of this in a moment. Okay, so let's do the symbol. Okay, so let's say you had P. P is a statement, Q is a statement, and what that means is that contrapositive means if you have P, then you have Q. Okay, that's what that little arrow means. Okay, it's an if-then situation. If you have this, then you have that. Okay, and I'm just speaking in terms of what it means rather than just throwing in an example, because I will do that in a moment. Okay, that can be replaced with if you negate both of them. Remember, the definition is switching the hypotenuse and the conclusion. The P is often the hypothesis, the Q is often the conclusion. So if you have two statements, the first statement, you know, if P, that's generally the hypothesis, and then the following statement, which is represented by Q, is the conclusion. So if you switch those and negate both of those statements, you have this. If I switch Q, put Q up front, negate it, okay, and then you also have this, okay? So if you have Q, then you have P, and then you make both of them negative or not, okay? So what is that? So actually it reads just like this. It reads just like this, okay? If not Q, then not P. That's how you would read it, okay? And to get a better sense of what it means, okay, you can just think of the following example, okay? So this is the contrapositive, right? And an example of that would be if two angles Whoops, I'm sorry here. I wrote too close there. You know what? I wanted to. Okay, hold on. Let me go ahead and rewrite that. Give me. Okay, so let's look at an example of an original statement. If two angles are congruent, right? That's your P statement. Then they have the same measurements. That would be your Q statement. So if, right, P, then Q. Okay? And you notice the comma right there separates your P statement to the left and then the Q statement to the right. All right? And that's what this means here that I'm underlining right there. Okay? Well, if you want the contrapositive, you need to switch both the Q and the P. The Q needs to come out front. The P statement needs to go to the back. Okay? And so the contrapositives is that, and you also have to negate them as well. So you're not only switching them, but you're making them both negative by putting the word not. So you got to remember that as well. It's like a two-step process, right? Switch the P and Q and make them not, both not. Well, let's take the Q statement and put it out front and make it negative, okay? If two angles do not, okay, have the same measure, right? That's your Q statement. I put it out front and I made it negative by putting the word not. Then they are not congruent. Okay? So you switch the Q and the P and the Q and make them both not, and you can do that with any statement and you'll get the contrapositive. Whether it's true or not, you can still get the contrapositive, and then you can determine whether a statement is true or not. And that's what logic is, okay? It's taking these statements and rearranging them many different ways and see what the truth is. And that's when we do truth tables, okay, which we'll do on in the next video, okay? So you have many different examples of that. In my next video, I'll talk about more examples of logic statements. Thank you.